All right, everyone. So let's go ahead and take a look at um, creating a confidence interval for proportion. So remember that the confidence interval is pretty much confidence interval here is in essence an interval which will contain the true proportion, or we hope. All right. So if we can somehow create a confidence interval, then it gives us an idea of what the true population proportion will be. And last time we saw that it's essentially the point estimate p hat plus or minus the margin of error. And we saw that the margin of error is basically the number of standard deviations times the approximated standard error. We do have some requirements, and they should make a lot of sense. One is that in order for us to guarantee that p hat is indeed close to p, we require an actual valid random sample. So usually we'll shorten that to SRS. And two is that we require independence among the individual selected. So we can achieve that by ensuring that my sample size is less than 5% of the population. And finally, the third condition, n times p hat times 1 minus p hat greater than 10. That's pretty much our shape requirement. So if this is true, then that essentially guarantees that we're going to have a distribution of sample proportions approximately normal. And the beauty of this is in the previous video, we saw how to use the formula to do this by hand, and hopefully we know why this works. But because we have StatCrunch, it makes it so much easier. So in StatCrunch, we're just going to go ahead and say, we can go to stats, you select proportion stats, one sample with summary, and we're going to click confidence interval for P. So remember that all of this is us trying to make some kind of statement regarding the population parameter. So it's a value that's in the clouds because we don't actually have access to it. All we have access to is our sample. So let's take a look at our first example here. A researcher for the US Treasury wishes to estimate the percentage of Americans who support abolishing the penny. So the penny itself actually costs more to make to the US Mint than the coin that is worth. It's like building something, getting paid, and then the object that you build is worth less than what you're paid. So abolishing the penny has been one of those ideas that has been put forward. I think, every several years it kind of comes back up into the discussion. Now, the question is, if you're president and you're proposing something like this, are you going to create a group of people that are upset? And is that group going to be very large? Or do people not really care? So it's really important for us to have answers to this. Let's go and answer the first question. So what is the population? If a researcher wants to estimate the percentage of Americans who support abolishing the penny, so what is the population? What group is he interested in? Essentially people in the US, right? AKA Americans. Now, what is the parameter of interest? So if that's my population, what's the parameter here? The parameter is the value that I do not have, and that would be P, the population proportion. And so I'm just going to go P, which is equal to the true proportion of people in the US who support abolishing the penny. So in essence, this is chapter 1. This is what you were asked to complete in chapter 1. So hopefully this is making a lot of sense. We've got our population of interest, and we know that a parameter is the value that describes that population, and we don't have access to that right now. So for part T, it says obtain a point estimate for the population proportion of Americans who support abolishing the penny. So the keyword here is point estimate. So let's estimate what this value of P could be. So again, this is the value in the clouds. We're always going to estimate using the sample. So in our problem, they have this sample. They have a sample of 1,750 people. And notice that out of all of those, only 263 are in favor of abolishing the penny. All right, so my point estimate, the value that I get that can approximate this, right? So the idea is that this is my best guess as to what P is. It's always equal to X over N, where X is the number of people who agree or who say yes to your question. In this case, it's 263 divided by N, which is 1750. So throw that into a calculator and we get our best guess as to what P could be. So there we have it. We have our point estimate. It's in essence the sample proportion. All right, now that I've got my point estimate, so I'm pretty much at this stage right here, point estimate, I want to go ahead and make sure I meet the requirement, because in order for me to get a confidence interval, I actually am using the idea that P, the sampling distribution of sample proportions follows this nice symmetric bell curve, right? So we know where we expect to land, what fraction of the time we'll get a result that's close enough, and so on. So let's verify the requirements. So requirement number 1, do we have a simple random sample? And this one is going to be safe to assume because we already did this and we saw the importance of a simple random sample, a valid random sample in lab 1. So from here on out, anytime that you have a sample, we're going to assume that the person also is aware of the pitfalls of not having a valid sample. So we're going to assume they took a simple random sample. Number 2, do we have the independence condition? So is n less than or equal to 0.05 times capital N? And this one, again, we're going to check it off, safe to assume. And it's safe to assume because N, big N right here, in this case, it's like 300, at least 300 million. So as long as my sample size is less than 5% of 300 million, we're going to be okay. And we saw last time that for a population size of like 250,000, that, N could still be in the thousands and meet that condition. So from here on out, we're just going to say safe to assume. You can actually compute this, by the way. But anyway, let's go ahead and take a look at the shape condition. So is N times P times 1 minus P greater than or equal to 10? I don't have P, so we're going to be using the sample proportion, which we found in part C. So all we do is we substitute. So we're going to go ahead and figure out what is N, which is 1750. When I multiply it with P hat, 0.10529 times 1 minus P hat, 0.15029. So throw that into a calculator and see what you get. So I get roughly 223.48, which is in fact bigger than 10, so we're good to go. We have all of the requirements met, so I can make a confidence interval. Now for part 3, it says construct a 90% confidence interval. So you could do this by hand, but we're not going to do this by hand. So now that you know the confidence level, you can go ahead and find Z alpha over 2 because we saw how to find the critical values before. So you can do that. And then we already found P hat. So then therefore you can find sigma of P hat, right? The approximated standard error. And then you multiply them and then you add and subtract that quantity. So I showed you how to do this by hand last time, but you saw that it takes a little bit of time. And for us, we really just want to create the confidence interval. So I'm going to go to StatCrunch and we go to stats. And remember, we're dealing with proportion. So it's proportion stats. How many samples do you have? I only have 1. In chapter 11 and 12, actually 11, 12, and 13, we're going to be dealing with multiple samples or multiple groups. So in this case, I only have a single group, the people in the US. So it's 1 sample. Now, do you have data or do you have a summary? Well, I don't have the actual data, right? The actual replies of the 1,700 individuals. I only have the summary. How many said yes? How many said no? And so there we go. Number of successes is 263. And number of observations is 1750. So we're going to type in 1750. And that's pretty much it. We're now at that stage where we want to tell StatCrunch perform a confidence interval for P. Make sure you update the level of confidence, which I believe was 90. Yep, 90. And that's about it. Go ahead and hit enter. And you've got your results. So we can just verify that we got the same thing, right? Here's X, here's N, here's P hat. Standard error, if you actually compute it, should be this value. And our final answer is the lower limit and upper limit. So this here is the confidence interval. All right, so I've now created a confidence interval with 0.1362, 0.164. All right, and now it says I want to interpret this. So let me actually type this out. And whenever you're asked to interpret this, it's always going to sound the same. Okay, you want to start by talking about what level of confidence you use. So we're going to say we are 90% confident that the true proportion of people in the US, and all that I'm going to do is basically type in what P is. Right, so I've got the level of confidence, and now I'm basically describing P. So true proportion of people in the US who support abolishing the penny. And what do we just see? That it's between these two values up here. Is between 0.1362 and 0.164. So it's a very small value. So let me emphasize how this interpretation piece works. You're always going to talk about the level of confidence. And then what you're doing is you're essentially writing down the parameter. Just the level of confidence, you write what your parameter is, and then you give me the interval. Notice that the parameter here that I'm talking about is the proportion. What you can do is you can swap these. Instead of saying proportion, you could replace that with percentage. And if you replace that with percentage, you just got to make this into a percentage. Remember, if it's 0.1362, all we do is we multiply by 100 and we'll get the percentage. So it'll be 13.62% and 16.4%. So we replace that here. And there we go. We've got our first complete confidence interval problem. So as you can see, the red portion is the StatCrunch part, and that's very fast. And so it's everything else, right? It's the setup that takes a long time. And that's going to be pretty similar for the rest of the class. It's always the setup that takes forever. The actual computation piece, we're going to use StatCrunch for. All right, so that was our first example. And what I want to do is I want to leave you with an example of your own. So go ahead and apply the same strategies that we discussed above, same approach, and go ahead and complete example 3.